Question number 4. A boy runs from a point A to a point C. He pauses at C and then walks back towards A until reaching the point B, where he stops. The diagram shows graph of V against T, where V meters per second is the boy's velocity at time t seconds after leaving A. The boy runs and walks in the same straight line throughout. Find the distance AC and AB. Okay, so the boy starts from a point A and moves to a point C. So first so he goes from A to C first. So here's, let's say, A and here's C. He pauses at C and then walks back towards A until he reaches point B. So first he's walking in this direction and then he starts going back. And he walks in this direction until he reaches B. So first he goes from A to C and then back from C to B. Okay. Says that the diagram shows the graph of velocity against time, where V is the boy's velocity at time t seconds after leaving A. Okay. The boy runs and walks in the same line throughout. Find the distance AC. Okay. So this shows the movement from A to C. Because it says a boy runs from point A to the point C. He pauses at C. So this is that pause. So that purple shaded area is the distance from AC. A to C. Now from O levels, we know that if the graph is a velocity time graph or a speed time graph, you can find distance through area. So for part 1, distance AC is area of this rectangle, which is 7 times 10, which is 70 meters. Do we have a unit mentioned here? Yeah, 70 meters, since it says meters per second. Okay, so that's the distance from A to C. The second part of journey is the distance from C to B after the wait period. So this is the distance between C to B. Let's find that out as well. So this would be 4 times 15, which is 60. So this distance is 60 meters. And the distance from O to A to C is 70 meters. So then what should be the distance from A to B? That would be 70 minus 60, which is 10. So the answer for part 1 would be 70 minus 60, which is 10 meters. Okay, that's the correct answer. Okay, so what did we do in part 1? We first found the distance from A to C, which is the area of the first bar shown in the figure. And then we found the area or the distance from C to B, which is the area of the second bar shown in the graph. And then you subtract the two to find this distance from A to C. Okay, so the answer for the first part was 1, and for AC, and then for AB, this was the working. Okay. Part 2 says sketch the graph of X against T. What was X? The distance. Where X meters is the boy's displacement from A. Show clearly the values of T and X when the boy arrives at C, when he leaves C, and when he arrives at B. Okay, so now we have to draw a displacement time graph. So time would be on the x-axis, unit is seconds. Displacement would be on the y-axis. Displacement and the unit would be meters. Okay. So firstly, he starts at A. So at A, of course, the displacement is 0. Displacement is the shortest distance from the starting point. So at A, the displacement is 0. Then from A to C, the distance is 70 and the displacement is also 70. Displacement is the shortest distance between 2 points. So it's going to be 70. So let's make a line going up. It has some certain speed and then it reaches 70. So this would be 70. And he reaches 70 at 10 seconds. So this would be 10. The displacement is 70 when the time is 10 seconds. Then for the next 5 seconds, we see that he was at rest. So then the line stays straight. The displacement is still 70. So straight line till 15. And then as the boy goes from A to B, the displacement starts to decrease. Displacement is the shortest distance from the point where the boy is to the starting point, which is A. So as he starts going back from C to B, the displacement starts to decrease and then it finally reaches 10 meters because remember this distance was 10 meters. And reaches 10 meter at the 30th second. So we need to show 30 on the x-axis. So this is 15, so 30 would be here. 30 seconds, and at 30 seconds, the displacement is 10. Let's say 10 is here. So then you draw a line like this. This would be the displacement time graph. Any questions? I hope you know the difference between displacement and distance. The distance increases as you go from one to the second point, but the displacement might increase or decrease because displacement is the shortest distance from the original point. Okay, if there are no questions, then we start our classwork today. Okay, so I'm skipping question number 5 because it's supposed to be done with the topic of kinematics. It shouldn't have been in this worksheet. So I'm skipping 5 for now. We're starting question 6. The diagram shows velocity time graph for a lift moving between floors in a building. The graph consists of a straight line segments straight line segments. In the first stage, the lift travels downwards from the ground floor. Okay, let's see. So this is the first stage of the graph. It says that in the first stage, the lift travels downwards from the ground floor. So they've shown downward motion underneath the x-axis. Okay. So they've shown that with the negative velocity. So as the lift goes down, they're showing that with negative velocity, and as the lift goes up, the value starts becoming positive. Okay. So in the first stage, the lift travels downwards from the ground floor for 5 seconds. So this is still the lift going downwards. The part of the graph, which is below the x-axis, represents the motion of the lift going downwards. So in the first 5 seconds, the lift is going downwards. What's happening? First, this velocity was zero, and then the velocity is increasing, increasing, increasing as the lift goes down. Then it starts to decrease and starts becoming zero. So what's happening is that here's the lift at ground floor. On the ground floor, it starts going down. It first has increases its speed, and then it starts to slow down as it goes down, and eventually it stops because the speed again becomes zero. So this part of the journey where the graph starts going down first with a greater speed, and then eventually the speed begins to decrease and becomes zero. So that part of the motion of the lift is shown by this V. First, the speed is zero, then the speed starts increasing. It increases to a certain maximum value. For example, this is -4. The minus only shows that downward motion is being represented by a negative sign. So as the lift is going down, its velocity is shown by a negative sign. And when the lift will go up, the velocity will have a positive sign. Since velocity is a vector quantity and negative is the direction, which is downwards. Okay. Then what happens is, so this 5 seconds. Yeah, it says 5 seconds here. Okay. Coming to rest at the basement after traveling 10 meters. So this distance is 10 meters. That means distance is area under the graph, remember? So this area should be 10 meters. Since distance is area. Yeah, okay. Okay. Coming to rest at the basement after traveling 10 meters. Okay, so then it comes to rest. It stops moving, as we can see by this line. So it's not moving. Its velocity is zero between 5 seconds to 15 seconds. So it stops at the basement for 10 seconds. The second stage consists of a 10-second wait, which we've already discussed, at the basement. In the third stage, the lift travels upwards. So then this lift starts going upwards. So now it's going in this direction. In the third stage, the lift travels upwards until it comes to rest at a floor 34.5 meters above the basement. So this is that motion. This, and this. The lift is going upwards in this part of the graph. First, its speed increases from 0 to a certain value v, and then it stays at that speed for a particular time, and then the speed begins to decrease while it's going up, and eventually it comes to rest. So it keeps going up and then starts decreasing its speed, and eventually the speed becomes zero at a certain floor, and you're told that this distance covered is 34.5 meters. So from the basement to this particular floor, the distance is 34.5, and we know that distance is area again, so that means the area of this green region is 34.5 from basement till the particular floor. So this is 34.5 meters. Arriving 24.5 seconds after the start of the third stage, we can see that here. Okay, the lift accelerates at 2 meters per second for the first 3 seconds of the third stage. So they've given you the acceleration for this stage. So this acceleration is 2 meters per second square. For the first 3 seconds of the third stage, reaching the speed of v, find the value of v. Okay, so we need this maximum speed. Oh, I had missed part one. Part one bhi to tha. Okay, let's go back to part one. So in part one, they're only discussing the first part of the journey that has been shaded with pink. Find the greatest speed reached during this stage. Okay, so the greatest speed is this value on the y-axis. We need this value, let's call it x. Okay, and we know the area of this triangle, which is 10. And we also know the base of this triangle, which is 5. What we need is the height, this distance. So we can use the formula for area. So for part 1, you will do area equals half times base times height. Area is the distance. So 10 equals half times 5 times x. So area equals, sorry, x equals 4. So find the value of, find the greatest speed reached during the stage. So the greatest speed is 4. Had they asked for the velocity, you would have written -4. But speed is just the magnitude of the velocity. So greatest speed would be just 4, not -4. Okay, 4 meters per second. Okay, next part. Um, find the value of v. Okay, so for v, what we can do is look at this part of the journey. Because here the speed goes from 0 to the highest speed, which is v, which we have to find. Okay, so we don't have the distance of this part. We have the distance of the entire green part, not the orange part. But what do we know about this part? We know that at the start of this stage, the speed is 0. And at the end of the stage, the speed is v. So we know u is 0 and v is capital V. Also, we know the acceleration of this stage, which is 2 meters per second. Also, we know the time of this part. It goes from 15 to 18, so that's 3 seconds. So now we can use equation of motion to find the value of capital V. Okay, so we can use V is equals to U plus AT. So V equals 0 plus 2 times 3. So V is equals to 6 meters per second. So this highest value of speed is 6. Part 3 is find the time during this third stage for which the lift is moving at a constant speed. Okay. So when is the lift moving at a constant speed? From here to here. So you need the time duration for which the lift is moving at a constant speed. So basically you need the time from here to here. So that would be one of the parallel sides of the trapezium, this side. Also, we know the area of the trapezium, which is the distance covered in the third stage. That's 34.5. So we can use the formula for area of the trapezium and find one of the parallel sides. So that should be area, which is 34.5 equals area of trapezium is half times height times sum of parallel sides. Let's call it A plus B. So 34.5 equals half times height is 6. Height is this distance, which is 6, times sum of parallel side. One of the parallel side is, let's call it X, and the other parallel side is, in fact, we've used X before, let's call it Y, plus the other parallel side is the distance from 15 to 24.5. So that's 9.5. This distance is 9.5. So plus 9.5. Move it around, cross multiply and all, and find the value of y. बताना क्या थी? What do we get for this?
Two.
2? Yes, 2 is correct. It's going to be 2. It was the time. So time duration, so it's going to be in seconds. Okay. Part 4, deceleration of the lift in the final part of the stage, which means they're talking about this final falling line. Deceleration in the third part of the movement of the lift. So how do I find the deceleration here?
बस gradient निकालेंगे लाइन का.
You can use the gradient method, rise over run, or y2 minus y1 over x2 minus x1, or you can use one of the equations of motions as well. I would personally prefer gradient because that is what we were used to in O levels. So deceleration or acceleration is just the gradient, which is rise over run. So you don't even have to worry about the sign. Deceleration is actually negative. But when you're mentioning the deceleration, you just mention the magnitude because deceleration by default means negative acceleration. So it should be rise is here to here, which is V was 6. So 6 units is the rise over run is from here to here. So that goes from 9.5 to 24.5. So 24.5 minus 9.5. 16. So find this out. Sorry, it's 15, not 16. So 6 over 15 is 0.4, which is not the answer, which galat kiya. That's not 9.5. मैंने 9.5 कहाँ से लिख दिया? I don't know where that 9.5 came from. So not 9.5. वो ऊपर आया था 2 seconds. So this wait period is for 2 seconds. तो यहाँ पे time क्या होना चाहिए?
Miss 20.
हाँ, यहाँ पे 20 होना चाहिए. So this was 20, sorry. So we have to write, we have to find this run from here to here, which is 4.5. Which comes out to be 1.33333. So, or 4 over 3. Or 1 whole 1 by 3. Your answer should be a positive value. एक्सेलरेशन अगर पूछते तो हम कहते हैं नेगेटिव एक्सेलरेशन है -4/3। पर डिसेलरेशन पूछी है तो फिर उसके साथ आप पॉजिटिव साइन ही यूज करते हैं। That was question number 6. कोई क्वेश्चंस हैं इसमें तो प्लीज पूछ लो। Chapter 7 start
So I've
करते हैं।
noticed that M1 is pretty similar to like O-level physics का kinematics वगैरह का chapter. Like the questions are also quite similar.
To some extent, but completely नहीं। आपने तो नहीं की ली हुई ना फिजिक्स ओ लेवल्स में, तो ऐसा नहीं है कि
मैंने
हम्म
रखी हुई थी वो।
रखी हुई थी। हाँ, तो कुछ फॉर्मूलाज वगैरह और थ्योरी वही है, बट इतना न्यूमेरिकल बेस्ड नहीं होती मेरे ख्याल में ओ लेवल्स की फिजिक्स। मैंने तो खैर पढ़ाई नहीं हुई तो आई एम नॉट श्योर, बट आई हैवंट हर्ड दिस कमेंट फ्रॉम एनी ऑफ माय स्टूडेंट्स बिफोर कि उनको फिजिक्स लेके, क्योंकि फिजिक्स अच्छी थी तो फिर उनको मैकेनिक्स भी उनकी अच्छी है। इट हैज मोर टू डू विद द न्यूमेरिकल पार्ट्स ऑफ फिजिक्स। और उसके अलावा मैथ्स का भी बहुत ज्यादा ओवरलैप है। लाइक काइनेमेटिक्स तो हमने ओ लेवल्स में भी पढ़ी है, ये स्पीड टाइम ग्राफ, डिस्टेंस टाइम ग्राफ।
जी मिस।
ओके, अगला क्वेश्चन करते हैं। A car of mass 1200 kg travels on horizontal straight road with a constant acceleration a. Okay, so the acceleration is constant. The mass is 1200 kgs. Let me draw the figure. So here's the road, here's the car, and let's say this is the direction. Should be a horizontal direction. Okay. Given that the car speed increases from 10 to 25 while traveling a distance of 525, find the value of it. Okay, so part 1 does not require the figure. It says that the initial speed was 10, so u is 10. The final speed is 25, so v is 25. The distance is 525, so that's s, and you have to find a. You have 3 values, you need a 4th value. That means you're going to use equations of motion. Which one? There were 5. Which one are we? Hmm.
V square is equals to U square plus 2S.
Sorry, v square equals u square plus 2s. That uses all 4 of these mentioned values. Okay, so v is 25 square equals 10 square plus 2 times 8 times 525. Now please find a. Read, subtract, and then divide.
Hmm, 0.5.
0.5 आंसर लिखा हुआ है। 25 स्क्वायर minus 10 square 520।
0.5.
हाँ, 0.5।
मैम आपके पास ब्लैक बोर्ड।
अभी भी कर रही है। सिग्नल स्ट्रेंथ तो फुल है, लेकिन मुझे जूम वार्निंग दे रहा है इंटरनेट कनेक्शन अनस्टेबल के। आवाज आ रही है मेरी? और शुड आई कनेक्ट टू अनदर राउटर? किसी को नहीं मेरी आवाज आ रही? हेलो?
मैम आपकी आवाज।
ओके। Let me check. अब तो सही है, मैं तो काफी फास्ट
नहीं ऐसा
प्रोसेसिंग हो रही हूँ। अभी भी कर रही है लैग?
नहीं मैम, अब ठीक होगी।
ठीक है, ओके। अच्छा, वापस जाते हैं तो इसमें we just use equations of motion to find acceleration in part 1. Let's look at part 2. The car engine exerts a constant driving force of 900 newtons. So ये एक force है कार पे, and the resistance to the motion of a car is constant and is equals to R. Find the value of R. So now what will be this 900 Newton force on the car and what is going to be that R?
Is the 900 will be the forward
Yes,
force and the
exactly.
R will be the backward.
Exactly. Yes. So forward force minus backward force equals mass times acceleration. Mass is 1200. Acceleration is 0.5. So tell me what R is from here.
ठीक
300. फोर्स है तो फिर यूनिट हो गया न्यूटन. नेक्स्ट क्वेश्चन. Okay. The diagram shows the velocity time graph for the motion of a small stone which falls vertically from rest at a point A above the surface of the liquid in the container. The downward velocity of the stone t seconds after leaving A is this. अच्छा पहले तो मैं figure बनाऊं. Okay, so there's a stone और ये कोई point A है. यहाँ से drop होता है, नीचे जाना शुरू हुआ. तो शुरू में दिखाया हुआ है that the speed is 0. So इधर u होगी 0, u equals to 0. And as it drops, of course, its speed is the speed will start to increase. And we can see that it's increasing, it's increasing, it's increasing, and it goes till 7. And then it hits the surface of a liquid. So यहाँ कहीं liquid है, उससे पहले स्पीड इंक्रीज हो रही है और वो आ जाती है यहाँ पे 7 meters per second. And now, since it has entered into the liquid, now the speed starts to decrease और वो कम होना शुरू हो गई है and it stops at 5. At 5, it must hit the bottom. The downward velocity of the stone t seconds after leaving A is v. The stone hits the surface of the liquid with velocity 7 meters per second at time 0.7. ये टाइम दिखाया हुआ है जब वाटर को हिट करता है. It reaches the bottom of the container when the velocity is 5 at time 1.2. So yes, when it reaches the bottom, this is the bottom, its speed is now 5 meters per second. And the time is shown on the graph. Okay. Uh, find the height of A above the surface of the liquid. So you need this height. ये कैसे आएगी? You need either you need this height or you need this area. Both should give you the same answer. Because in the distance time, speed time graph, the distance is the area under the graph. So let's use the area option. So part 1, A, I'm using the area of this triangle. So half times base times height, which is 2.45. Okay. Or you could have also used equation of motion here if you were using this part. So I was saying that if you use this part, then you can also find this using equations of motion. What do we know here? That u is 0 and that v is 7 and also the time taken is 0.7. So t is 0.7 and you need s. So you can also use v square equals, no, not this one. S equals half u plus v times t. This will also give you the same answer, which is 2.45. Okay. But so let me substitute the values. Half 0 plus 7 times 0.7 gives 2.45. Okay. Okay. Part 1A is done. What's part B? The depth of the liquid in the container. Okay. So that is this distance. Again, you could either use equations of motion or you can find area of this part of the graph. Okay, let's use both. So if you're using area, you have to use half times height times sum of parallel sides. So half is half. Height is the distance between the two parallel sides. So if this is the trapezium, then this is the height, which is 0.7 till 1.2. So that's 0.5 units. So the height is 0.5. And then A plus B is, this could be A, this could be B, the sum of parallel sides, one of which is 7 and the other one is 5. This would give you the distance, which is 3 meters. Or you can use equations of motion. Now in this part of the journey, u is 7, v is 5, and also the time taken is, we've seen from here, it's 0.5 seconds. And you need s. So same formula, s equals half u plus vt. When you substitute the values, you should get the same answer, which was 3. Okay. Let me see if we can squeeze in one more question. Yes, we can do 9. Sorry, 9 मैं अभी नहीं कराती, थोड़ा लेंदी है. 10 करा दे. We can do 10. Okay. A block is at rest on a rough horizontal plane. The coefficient of friction between the block and the plane is 1.25. Okay, so there's a block which is at rest on a horizontal plane. The coefficient of friction, that is the mu, is this. That means we're most likely using friction equals mu r, where r is the normal contact force. State, giving a reason for your answer, whether the minimum vertical force required to move the block is greater or less than the minimum horizontal force required to move the block. Okay. So vertical force kitni chahiye hogi if you want to pick this block up? The downward force is mg and the upward force is the normal contact force. So if you want to pick this up, तो आप जो फोर्स अप्लाई कर रहे हो वो वेट से ज्यादा होनी चाहिए. So vertical minimum vertical force would be minimum force vertical should be equals to or slightly higher than mg. G is going to be 10, so 10 m. This is the vertical force that you need to move this. Okay. And then what's the minimum horizontal force you need to move this block? If it's moving in this direction, rightwards, then this is the forward force and this is the backward force. Backward force we know is mu r. So the forward force must at least be equals to mu r. In fact, slightly bigger than mu r so that it moves. So I'm going to equate these. Forward force, or let's call it horizontal force in this case. Minimum horizontal force should be greater than mu r. So mu is 1.25 and r is again 10 m. The normal contact force, this was 10 m. So it's actually greater, it's 12.5 m FH. So we can see that FH, the horizontal force needed to move the block, is greater than the vertical force needed to move the block. Let me check the answer. Side. A horizontal force of continuously increasing magnitude Pn and fixed direction is applied to the block. So now the forward force is P. Given that the weight of the block is 60 newtons, so that means you know the downward force now. This becomes 60 newtons. Let me redraw the figure. So now there's a forward force, P. There's a weight, 60 newtons. There's an opposing normal contact force, R. And then there's a friction, which was mu R. Okay. So given that the weight of the block is 60 newtons, find the value of P. Acha, if weight is 60 newtons, what's going to be the mass? Weight is 60 newtons. So mass क्या होगा?
6 kg.
क्या? Sorry?
6 kg.
6 kgs. ठीक है. Mass is weight is equals to mg. So 60 equals 10 m. So m is equals to 6. So we're going to use forward force minus backward force equals ma. Forward is P, backward is mu R equals ma. P minus mu was 1.25. R balance कर रहा है weight को, so R is going to be 60 equals m6 है और A हमें बता दिया है 4. So इससे P आ जाए. Which should come out to be 99. Okay, that's all for today from mechanics. मैं एक दो क्वेश्चन होमवर्क में दूंगी, वो करके आने हैं ताकि ये वाली वर्कशीट जल्दी खत्म हो और हम अगली वर्कशीट पे जाएं. Let's start the pure homework correction now.